we are going to be investigating the valence electron shell pair repulsion model and how we can predict molecule shapes based on that. Now, the main concept here is that electrons tend to repel each other, and so when molecules form their various shapes, they're going to arrange themselves so that the bonding pairs and the lone pairs minimize the repulsion. And so you can see if I add another bonding pair to this molecule, these bonding electrons spread out to minimize the repulsion. Now, this gives our molecule a geometry, and when you click this is a trigonal planar molecule, and it just makes sense because it's a triangle, and if you turn it a certain way, it's a plane. Now, there's a second thing to consider. In terms of electron geometry, this is also trigonal planar because the electrons are all in a triangular plane. Okay, what happens though if there happens to be a lone pair? And so let's take a look at the case of water. And so this could be an oxygen and two hydrogen molecules. And when we do the Lewis structure for water, we know there are two lone pairs of electrons involved as well. We don't see them when we look at the molecule, but they're there and they're repelling things. So there's the first lone pair, and it's made it into kind of a bent shape. So if I looked at the molecule, I would say, oh yeah, it's bent. If I add another lone pair, you can see that the molecule has changed again. And in this case, it's still bent. The bond angle has changed to 109.5. Now, the significant thing is the electron geometry. And so when you look at this molecule in terms of all of the electrons, the bonding pairs, and the lone pairs, this is a tetrahedral molecule with respect to the electron geometry. And it's bent with respect to the actual molecular geometry. And so you're going to be inventorying all the various combinations of bonding pairs and lone pairs and how they influence the geometry of the molecule.